Hey guys, welcome back again to yet another YouTube video from our channel Fly by Mike. Today we're going to look at the oscilloscope, and because when you use the oscilloscope it accepts frequencies or electrical waves, so we need to have a wave generator. So we have which is going to generate electrical waves, which we are going to use by the oscilloscope. So over here, let's begin from here. This particular function generator emits frequencies all the way from 1 to 1 million hertz, and we can manipulate the shape of the waves. We can have a square wave, we can have a sine wave, and the V wave. So as you can see, what I'm doing here is like I'm trying to manipulate the shape of the wave. We have this one and we also have this one. So we have 3 different waveforms. That is all about the functions of the buttons on top here. What we have here is just a final adjustment of the frequency, because this is just a range. Like what I've clicked right here is 100. But if I want it to be like 206 hertz, then I'll have to adjust it with the frequency adjuster. This is the power button, this is the input, VCF, the TTL, and we have the output here. So from the output we'll use a BNC connector, which will bring the wave into the oscilloscope. So in the oscilloscope we've plugged it into channel 2, and we've set up the frequency so that we can better view it from our screen over there. So this will manipulate the amplitude, this will manipulate the wavelength, so that you can fit well on the screen. We also have a positioning over here, so we can bring the wave down, we can bring it up, so that we can better see it, of course, and the intensity as well, we can reduce it or increase it so that it becomes brighter. Also the focus can be manipulated so that it can be maybe dim or a bit sharp, a sharp image. So that is about the oscilloscope. And we also have an hold off, so if we want to have the wave to stand so that we can measure its amplitude, we'll use the hold off knob over there. We have 2 channels, which is channel 1 on this side and channel 2. So this helps us to add the frequencies if we are having 2 inputs, so and we want to find the sum of them. Then we just plug them all, then we put this setting at both. When you put it at both, it's going to show all the waves. When you put it at channel 1, it's going to show what you put at channel 1, which right now it's not in use, so it's just a flat trace. So let's take it back to channel 2 so that we can see this wave. This wave is a 206 hertz wave, and we can also calculate that from here, from the settings of how we've done it. In its x-axis we have the second slash division, which is currently at 1 millisecond. So that means one single square on the screen represents 1 millisecond. And if we want to find the wavelength of this wave, then we just better calculate it by counting the number of full squares and the single divisions that we have over there. If you want to measure the amplitude is of course adjusted by this knob over here, which is in volts per division. So currently it's at 1, so which means one square represents 1 volt. If we put it somewhere maybe at 0.5, then it means 1 square will represent 0.5 of a volt. So we just count the number of full squares again and the number of the smaller divisions over there, and we're able to use those to calculate the frequency, calculate the wavelength and the amplitude. So that is all about the oscilloscope. Tune in for more innovative or educative videos from Fly by Mike. See you next time.